Let's take a faraway voyage into the voids of time, to a place without sadness or despair, and where love will never die. A land without troubles or doom, the place they call the far side of the moon.
Giordano Bruno believed that the moon was inhabited. Johannes Kepler even wrote a whole thesis on lunar life forms. It was only a theory, but any theory requires scientific evidence or disproof. Man required new knowledge. Through a telescope, it became clear that the moon had no atmosphere. Detailed lunar atlases were compiled with the help of photos, and interplanetary maps also convinced everyone that the far side of the moon was uninhabited. Still, it was a shame to leave the Earth's closest companion without life. That is why, from the 17th century, lunar craters were named after those to whom we owe new knowledge. One of the craters was given the name of Russian physicist Pyotr Lebedev. The sight of a flying comet is striking. It is the brightest point with a huge tail. Scientists estimated that when it approaches the sun, the comet tail begins to rise at a rate of 1,000,000 kilometers a day and reaches the distance of 100 million kilometers. Since the 18th century, it has been known that this comet tail inexplicably contradicts the universal law of gravity. The tail should be attracted by the sun, but instead it is repelled by it.
In the early 17th century, Johann Kepler supposed that comet tails were a stream of particles thrown off by light as the comet gets closer to the sun. Some were critical, as it was clear to everyone that light could have no effect on the particles. 2.5 centuries passed. In 1873, in A Treatise on Electricity and Magnetism, James Maxwell said, "The light causes pressure on the surface placed in the way of the light flux." He theoretically calculated the value of light pressure on solid bodies. Some scholars refuted this statement, and even the great Sir William Thomson felt embarrassed for his friend Maxwell. This mathematical theory remained just that, and to believe in it, it had to be proven in an experiment. Pyotr Lebedev was ready to take on such a task. The matter was not only about confirming Maxwell's conclusions. One of the fundamental laws of the universe was hidden behind the proof of light pressure.
Maxwell's theory proved a connection between the three natural phenomena: electricity, magnetism, and light. These three phenomena are so different that physicists had always examined them separately. Lebedev realized that Maxwell's theory could not only become the beginning of a new scientific path, but also lead to the understanding of common universal laws. He was a man who relished in unsolvable tasks and aimed to prove the pressure of light.
The idea that light can affect and determine the direction of a comet's tail was so amazing, so exciting, that it had to be explored. Such an inspiration simply had to be investigated. Lebedev did not want to abandon this striking idea. His inquiring mind drove him to follow it every step of the way.
Lebedev was 12 years old when a friend of his parents, an engineering officer named Alexander Beknev, came to visit at Christmas. In the evening, when everyone was in the living room, Beknev placed a plate and his officer's gloves on the table. He called these objects his electric machine, and then did magic tricks to conjure up real wonders. That night, Lebedev felt inspired. He realized that being a magician was full of wonder, but his future had already been decided. On March 8, 1866, Lebedev was born in Moscow to his parents, Nikolai and Alexandra. His father was very happy because his business would have an heir. After all, their daughters, Alexandra and Vera, showed no interest in commerce. Lebedev's father had a trading business, and in his eyes, commerce was of great influence and romance. At 10, Lebedev inquired after his father's business. "Dear Dad, I wonder if you're well and your trade is going well." The boy was soon sent to Petropavlovsk Commercial College, where he learned German and the art of precision. But nobody suspected what plans were running through his mind. However, Lebedev's diary revealed the truth.
Fear runs through me at the thought of the career to which I'm being prepared. For an unknown number of years to sit in a stuffy office on a high stool over open folios and mechanically rewrite letters and numbers, and a whole life like that.
Pyotr dreamt of becoming an engineer. He frantically aimed to invent something. At 16, the young man recorded in his diary more than 40 projects, improving the telephone, designing an aircraft, and developing a motorcycle. But this, of course, was not enough. There's a need to do something never done before. That is why Lebedev began to work on a perpetual motion machine. His diary includes notes next to projects such as invented before, absolutely impractical, and nonsense. On his 17th birthday, Lebedev wrote,
"The purest, highest love, inherent only to man, is the love for science, art, and homeland."
It was at a ball that Pyotr met a young Frenchwoman called Mademoiselle Boudet, and this lovely lady distracted him from the development of the dynamo machine. But he wrote in his diary,
"I will not fall in love. Otherwise everything will be in vain. I will be an attendant of science and a priest of electrical engineering, and I will work for the benefit of the public. Long live electricity, and let it glorify us forever and ever."
He had everything. He rode horses, he attended balls, and sailed his own boat. His father loved him. Pyotr didn't avoid entertainment, but when his parents remark, "If you go into the trade, you will live as well as now, and even better. If not, then your means will be quite different," to which he replied quite cheerfully, "Well, I'll have sausage and I'll still take up engineering." Lebedev became a student of the Imperial Moscow Technical School. Soon his enthusiasm and obvious originality convinced the owner of a machine-building factory to invest a large sum of money into a very profitable venture. Lebedev promised to design and build a unique, economical unipolar car, a direct current generator, and he did. It was 40 horsepower and 1,660 pounds in weight, but the current did not flow and the machine didn't work. To repay the costs, Lebedev worked as a technician at the plant for free.
The unfortunate experience that nearly crushed me into a powder gave me no rest until I could find a physical cause. The misfortune with the machine led to very persistent and versatile thinking on the cause of the phenomenon. Without noticing it, I turned from the technology to the sphere of science.
Your frantic energy, Pyotr, urgently needs an experienced supervisor, a prominent scientist, and I know one. In Germany, Strasbourg, he nurtures the largest physics school. His name is August Kundt, recommended his school professor, Vladimir Sheglaev.
When something happens, we often ask ourselves two questions. Why did this happen, and what for? The first question can often be answered straight away, but it's unwise to immediately seek an answer to the second question, as the answer is often in the future. Why did Lebedev fail? because he was young, enthusiastic, self-confident, and impatient. He understood it himself. And from the future, we can assume an answer to the second question: what for? To teach him to work skillfully, not be discouraged by failure, and understand the time it takes to achieve a goal. It taught him not to be an engineer, but to become a scientist and understand the way of the world. This experience provided a brief answer to the second question. It led to his great journey into science.
It's easy to say you have to go to Strasbourg. It's even easier, rather sweeter, to dream about it and imagine it as magic. But to leave everything behind, home, friends, and a very close friend in Sasha Eichenwald, with whom he had dreamt, made jokes, took pictures, and had fun in Sasha's father's Photoshop. Lebedev did not know then that a series of these photos would continue throughout his life. He did not know that the tradition to gather with friends on Thursday would also remain forever. They called themselves Thursday Men. It was great fun.
It was extremely interesting. We can only regret that we did not see it, because they all wrote poetry, they all played and gave performances, just for each other. They all painted, you know. Surprisingly, there were people of different professions. But they say a talented person is talented in everything. Tea parties were held in the yard. Very witty charades were played out, as my grandmother told me. It was very funny, and everyone took part in all this. All the Thursday men and their wives later too.
Another passion of Lebedev's was sport. He regularly attended the rowing club. Others who attended often boasted of their records. 2 visitors once crossed Moscow by the Moscow River non-stop. Lebedev declared, "I'd row non-stop from Moscow River to Oka River." He went rowing together with a friend, and when he rowed, the other one had slept. The record was broken. However, doing so much sport started to cause him heart problems. Lebedev tried not to let it bother him.
He just loved life. He loved life in all its manifestations. Well, you know, of course, out of this love, different people make different conclusions. Some people conclude that you cannot breathe and continue this life, but it seems to me he just wanted to take from life everything at once and at its fullest.
The joy of knowledge, freedom of creativity, and a great teacher. Even in his wildest dreams, he could never imagine how perfect the situation would be. Strasbourg University in the late 19th century was a center of scientific life in Europe, and it is to August Kuhn's merit because he created an excellent physics institute with an amazing facility for laboratories.
Kuhn was an amazing teacher. He could inspire his students to scientific research. He showed entertaining experiments, and his lectures encouraged the study of physics. Kuhn himself was primarily an experimental physicist, a classical physicist who wanted to closely analyze nature and visualize it.
Dear Mummy, I miss you a lot and gently hug you. Every day I fall in love with physics more and more. Soon, it seems to me, I'll lose myself. Now I no longer understand how one can exist without physics.
In Strasbourg, Lebedev met Boris Golitsyn, who would become an outstanding physicist and seismologist. The students didn't have enough time.
Dearest Mummy, all day long I'm busy with what I've wanted to do since I was 12, and I only have one problem. The day is too short.
Lebedev and Golitsyn thought of an ideal model of learning.
At lunch, one friend was reading to another. It is such poetry not to lose time. While you eat, I'll read what's new in science. When I'm eating, you'll read to me. It's wonderful.
Kunt had a warm attitude to the student from Russia and appreciated his passion. He even wrote an anecdote about him. Lebedev has a whole sea of ideas. There might be 20 pieces a day, and as a supervisor, I'm pleased, and I never get tired of thanking him, because half of his ideas get lost sooner than he can fulfill them.
My dear Mummy, there are moments when I think I've made a mistake, and all the trouble and inconvenience I caused you by moving to Strasbourg after Dad passed away were in vain and for my own pleasure.
But momentary doubts did not prevent his ambitious plans. Lebedev brilliantly defended his dissertation, received the degree of Doctor of Natural Philosophy, and formulated an idea that led to some of the greatest experiments. The family received a very excited letter.
I think I've made a very important discovery in the theory of motion of celestial bodies. The work is theoretical. I'm writing a synopsis. Please, not a word to anyone.
Pyotr sent greetings to his favorite sister, Alexandra, with the hope that upon his return, they would go on a fabulous journey.
My grandmother, in fact, dedicated all her life to her brother. They traveled together a lot, and we keep a great number of albums of their travels. A variety of places, different countries, and a lot of pictures, because Pyotr loved taking pictures. There have been a lot of memories left from my grandmother, where she wrote about him. For her, he was like God, so to speak. And everywhere, Pyotr, Pyotr, Pyotr. This is the main figure of her memories. And of course, her life.
He was an excitable person, to set a task, solve it, as no one can, and to make a brilliant experiment that no one can do. It's like a victory in sport. It's understandable why Lebedev was so passionately fond of climbing. To conquer the highest point was vital to him.
But such was his nature, and his passion for science, sports, and all of that, I think just proved itself so. You need to live life to the fullest and take everything out of life, just because he was aware of the fact that his heart was not well, and he could not do this or that.
Maxwell's theory made it possible to solve the very old riddle. Lebedev prepared a report on the repulsive force of radiating bodies, where he brilliantly answered the question, why comet tails deviate.
Repulsive forces are caused by light pressure that is proportional to the area of a dust particle, and the force of gravitational attraction is proportional to the weight or the volume of a dust particle. The balance between these forces is not universal. For particles smaller than 1/10 of a micron, Lebedev discovered that the repulsive force dominates.
The deviation of comet tails is accounted for by light pressure. The law I found applies to all celestial bodies. The happiest time of my life is my stay in Strasbourg. My further fate is a misty spot with a big question mark, but I know one thing. I will work, as long as my eyes can see and my head is clear.
Professor Stoletov and Professor Sokolov invited Lebedev to work as an assistant at the Department of Physics at Moscow University. The Moscow laboratory was not as advanced as Kunst. To implement Lebedev's plans, a new laboratory and workshop were required. Why does the university need a lathe? Asked the board of the university, having looked through Lebedev's estimate.
Every physicist should be able to cut and shave, as well as to differentiate and integrate.
But the board did not agree. However, Stoletov and Lebedev had a little trick. They replaced the word lathe with the word accurate Trebanka, which derives from the German Trebank, meaning lathe. The board fell for it and signed the bill. Creating the Physics Institute was what Lebedev had dreamed of. He was one of the first to understand how effective the collective form of research could be. This scientist from Russia carries laws of the universe in the pocket of his coat. Whispered visitors of physical lectures that Lebedev conducted in Europe, where he went a few times to treat his heart. Leaving behind the great Hertz, Lebedev received the shortest electromagnetic waves of the time. Hertz needed a huge prism of 600 kilos. Lebedev's prism weighed about 2 grams, and the resonator with a complex device even less than 1 gram.
Lebedev was a bright literary talent and had a great sense of humor. He could not only write beautifully, but also speak so that others wanted to listen. Once he was asked, "Pyotr Nikolaevich, what is your opinion regarding the dissertation of Mr. N?" You see, he defended his dissertation under Professor M, and the professor had logical thinking. What is impossible to understand is called physics. Mr. N's dissertation cannot be understood, therefore he deserves to be a doctor of physics. Once a colleague was moaning about a vacuum device from which they could not entirely pump out the air. Joking with his colleague, Lebedev said, "I wish you were empty." Once surprised at a large number of questions at the master's exam, Lebedev said, "My bookcase knows much more than me, but it is not a physicist, and I am a physicist."
Lebedev finally married at the age of 42. One day he asked his colleague, "Have you ever been a witness of the wedding of your wife?" "I have." Showing an old photograph, he explained that many years previously, a sister of his friend was getting married and he was witnessed at her wedding. And now, years later, Lebedev married the same lady, Valentina Deryagina, née Eichenwald. In 1899, Lebedev took up the task that had evaded everybody, proving the pressure of light on solids. 3 years of work took him to the limit and caused extreme fatigue and heart attacks. Doctors demanded he give up work or he'd die. Lebedev replied, "Let me die, but I will complete my work."
What was the challenge that Lebedev met? The challenge was to find this pressure in laboratory conditions and measure its value. It was considered impossible to measure the pressure of light. Many scientists believe that the effect is so small that it is camouflaged by related factors that cannot be identified. Lebedev invented a sophisticated experiment, a really sophisticated one, to circumvent all these factors. It's like a sport, you might say. He managed to do it. It's great.
Inside the vessel on quartz fiber, there's a frame with wings. The light of the voltage arc puts different pressures on dark silvered wings, and the value of light pressure is measured by the angle of the twisted fiber. It's simple, but in reality, behind this simplicity are seemingly impossible obstacles. Firstly, the radiometric forces. Gas molecules are reflected from the hotter side of the wings and transfer impulses to them, thereby turning the wings but under a different force, rather than the force of light pressure. Lebedev made extremely thin wings. The temperature of the size became almost the same. And to reduce the gas molecules in the vessel, a high vacuum was created. But the rest of the molecules derived energy from the vessel walls. Lebedev reduced the heat of the glass through the heat filter. The second obstacle was the convectional power. It's impossible to hang the wing vertically because conventional currents deflect it, which arise under heating of the wings. And another brilliant solution. A specially designed device causes the light beam to focus on the wings either from one or the other side. In one case, the convection force adds up to the force of the light pressure, while in the other, it is subtracted. And now, convection does not interfere with measuring of light pressure. Demonstrating the unique art of experimentation, Lebedev proved Maxwell's theoretical calculations, and it was true magic created by his own hands.
This force of light pressure has been elusive and impossible to capture and measure. Lebedev was the first to do it. And so, an idea that had been discussed in science for a long time now became a scientific fact.
The extraordinary question had now found an answer. World-famous scientists send congratulations. Maxwell was not alive then, and his friend, the great Sir William Thomson, said, "All my life I fought with Maxwell, not recognizing his light pressure. And now, your Lebedev has made me reconsider because of his experiences." In 1901, Lebedev became a professor at Moscow University. Now he was once again looking for an impossible task, and he found it. But his doctors prescribed essential rest and long-term treatment for his health. In Heidelberg, in Germany, Lebedev visited the observatory of the famous astronomer Maximilian Wolf. Wolf met Lebedev with undisguised delight.
Now, the eyes of all scientists of the world are turned towards you, and they are waiting for solutions of new mysteries of nature. What are your plans?
I'm going to measure the pressure of light on gases.
Gases? But I'm sorry, how to measure it? I think that a precise measuring device does not exist and will never exist.
The next day, having forgotten about his illness and the need for rest, Lebedev turned back to the north, Moscow, so that such a precise measuring instrument could be created. According to the theory, light pressure on gases is hundreds of times smaller than the pressure on solids. In an experiment, you need to control innumerable molecules rushing about. Again, the magic was born. Once more, although it took 8 years to create new magic spells. 8 years of despair, disease, hope. During these 8 years, Lebedev was almost worn out. Countless options and solutions, improving instruments, the fight against convection currents, and other big obstacles. No one could repeat this experiment after Lebedev. No other scientist in the world could make mirrored light move along a wall, and the meter would not fix the value of the tiny and great power. The happy and very sick magician Pyotr Lebedev received letters from all over the world, full of wonder and admiration. The Royal Institute of Britain made him an honorary member. Prior to Lebedev, it was only Mikhail Lomonosov, from Russian scientists, who had received such an honor. Lebedev had often traveled actively to different countries, in any direction, to the south, west, east, to the peaks of the Alps, and to the foot of ancient temples. But one day, from all the directions, there were only two left, up and down. Up and down from the door of his apartment to the basement, where he had his laboratory, where all the students were waiting for him. When he could no longer go out, Lebedev moved to an apartment in the building of the university. Walking caused heart attacks, and he always carried painkillers. His student, Pyotr Lazarov, recalled.
From a young man, slender, handsome, without a single grey hair, Lebedev turned into a sick, grey-haired man. His eyes seemed to be looking somewhere past you, and his face acquired a special spiritual beauty, which is well known in the last portraits of Lebedev.
Even a brilliant teacher can find it difficult to create a scientific school. But Lebedev was able to establish a school that passes great learning from generation to generation. He did not like exams and lectures, although he was a great lecturer. But he was very fond of lively conversations, debates, and laboratory research. Despite restrictions imposed by his doctors, discussions could often last until very late at night. And, of course, with such a strict teacher, every physicist should be ready for hard work. In 1911, Moscow University was in trouble. The Minister of Education, Leo Cassot, published a memo on supervision of students of higher educational institutions, which undermined the autonomy of the university. In protest, the management of the university submitted their resignations. Cassot accepted the resignations and dismissed the rector and his assistants. Then, 130 lecturers and employees, including 21 professors, handed in their notice and stopped giving lectures. Lebedev had to make a decision.
Lebedev once said that his heart often started to hurt when he needed to make a choice. He took some time to think. These were the 2 hardest days of his life. How to leave? Where to? I can only be of use here. There's no decision to make. I'm staying. They've all gone. All the decent people have left. They've all made up their mind. And as though you have nothing to choose. Historians, lawyers, even doctors, they can leave immediately. But I have a laboratory. There's no me without a laboratory. Sasha Eichenwald is gone. Your friends are gone. How are you going to talk to them? Sit with them at the table drinking tea? But I'm not alone. Here are my students. If I leave, how about them? Would they stay? I stay for their sake. Have you decided? Yes. 2 days later, Lebedev left the university, and his disciples followed after him.
If it were not for the feeling that prevailed among the intellectuals at the time, if it were not for the decision of his colleagues and friends, Lebedev would never have left, no matter what. Banned gatherings of students or not, if it were possible to do scientific research, he would.
I always wonder why he left. I think he was just an example of an honest Russian scientist. As my grandmother told me, it was a terrible tragedy for him, because he left for nowhere.
He lost his house, work, and the meaning of life. These were awful losses. In general, he left the university for nothing, but he felt compelled to do it. He was a slave of honor.
Soon the scientific world knew what had happened. The director of the Physico-Chemical Nobel Institute in Stockholm, Svante Arrhenius, wrote, "For our institute, it would be a great honor if you wished to settle here and work." But Lebedev stayed in Russia. At the expense of Ledensov Society, supported by the Shanyavsky City University in Moscow, they started work on a new laboratory at number 20 Mертвый переулок, known as Dead Alley. That summer, Lebedev had to leave for medical treatment abroad, as his heart disease worsened. He left, but in early August, Pyotr Lazarev wrote to him that the new laboratory in Mертвый Alley was ready. Lebedev replied,
In a few days I will be in Moscow and will be heartily glad to personally make sure that together we will be doing lively work in Dead Alley.
Lebedev returned in September. He was again full of bright ideas. He said that his life was renewed. There was again a laboratory. The construction of Lebedev's Institute of Physics was started based on his design. Prospects were wonderful, but in January 1912, Lebedev again felt unwell. By February, he was gravely ill in bed, and on March 14th, Pyotr Lebedev passed away. A great loss at the age of 46. Scientists from all over the world responded to the news of his death. Condolences arrived in Russia from institutes worldwide.
Lebedev proved the existence of light pressure. His research was further developed by Einstein. The quantum theory, the development of thermodynamics and astrophysics. All this would be impossible without the proof of light pressure. Lebedev's experiments are a bridge that connects classical and modern physics.
The proof of existence of light pressure was of great philosophical and ideological significance. The electromagnetic field is characterized by impulse and mass. It is material, and therefore it exists not only in the form of substance, but also in the form of field. 4 years after Lebedev's death, the Institute of Physics was built and received the name of its founder. During the 20th century, 7 Nobel laureates would work there, and in honor of Lebedev, a scientific medal was named, as well as a street, a scientific research ship, and a crater on the far side of the moon.
Once, when his health was very poor, Lebedev said, "In my life, there was so little joy that I don't mind parting with it. The only pity is that a very useful machine for the study of nature is dying with me as well." As a boy, Lebedev had once been inspired by a visitor to his family home, Alexander Beknev, the magician who had made an electric machine from just a plate and his officer's gloves. He had thought how, if he became a magician, he would perform physical wonders and make everyone happy on the very big planet. But he had also thought how it's not possible to make the world happy in just 2 minutes. You need to go on a long, mysterious, fabulous, and very interesting journey.
I remember when I could forget all of my troubles and enjoy philosophical discussions with my friend Sasha Ekenwald. A wonderful shape appeared in the midst of a poetic pink haze of mystery. Then the haze dissipated, and I saw the strict eternal beauty of the universe. Purpose, meaning, joy, and all life in it and for it.
Concept and narration, Yaroslav Narcissov. Scriptwriter, Piotr Vinogradov. Director, Sergei Vinogradov. Translation and voiceovers by Alexei Bashko, James Brown, Michael Kravchenko, Yelena Sears, Richard Sears, Anastasia Trofimova, Natalia Vdovichenko, David Watson, and George Watts. The film was created with financial support from the medical research and production complex Biotics and the Scientific Research Institute of Cytochemistry and Molecular Pharmacology.